was actually a little bit weird for me to relate to because I don't eat melon. So I actually had to go to people and ask them what cantaloupe tastes like, which very awkward question to ask people, by the way. But anyways, he talks about cantaloupe because apparently cantaloupe, it's sweetest at a peak of ripeness. But right after it ripens, a chemical reaction happens in it that causes it to get soft and go bad. So this makes cantaloupe amazing for people who love it to eat, but it makes it really, really bad for it being transported across the nation or from one place to another because it will go bad before getting there. So what a scientist did is they developed this cantaloupe, which is the one that has lines going down them, which I believe is the ones that's sold in most stores. So what they did to it is they manipulated it in such a way where it will still have its firmness and it will still have its sweetness. But the way this cantaloupe grows, it grows in serendipity, which means first it takes about 10 years of crossbreeding and cross-pollination for it to even, for the breeders to get the recipe right. And even with that, sometimes it comes out and it's bitter or it's not as firm and it doesn't have the right combination of the firmness and the sweetness that they want. And they can't really know what cantaloupe is going to produce to actually after it harvests. So they have to wait from planting season to harvesting season to find out. Sometimes when they bring the harvest, most of it they wouldn't be able to sell it, so they'll lose most of it. So what some scientists decided to do is they decided to find a way to predict which seeds will have those genetic markers, the one of the right combination of the sweetness and the firmness before planting it. So the process involves a couple of robots. The first robot takes off a sliver of the seed. And the good thing about this is because only a sliver of the seed is taken off, the seed can still be plantable. The second robot extracts the DNA from that sliver of the choke and adds chemicals to it. And the third robot analyzes and amplifies the genes. And with the light emitted from that, it can measure to see if it has those genetic markers. And this whole process is actually called a marker-assisted backcrossing. Because what they do is they find out the seeds with the genes they need, and they could just plant that versus the conventional cross-pollination. They have to wait, and for every harvest, some of them might have that combination, some of them might not. So with this, it guarantees them that they're going to plant only the good seed, and they could save more of their harvest. One of the things I actually found this fascinating is that corn was actually one of the foods that was changed because corn was actually started as a grass that was modified into the corn we have now. And the same thing for broccoli, kale, Brussels sprouts, cabbage, cauliflower. These are started from a wild cabbage plant. These just, this paper, after that it goes into, the whole point of this paper is telling us how we can bring sweetness and firmness back to fruit without necessarily modifying it. Because the thing is, apparently people have a lot of misconceptions about genetic modification of food. Because they go to the store and they don't realize that about 70% of the things in the store are already genetically modified. So when they see fruits that are labeled as genetically modified, they get scared or say it's bad. But the thing is, most fruits actually are not genetically modified because it's not, there's no money in genetically modifying fruits and it takes too long and the companies do not want to do it. But foods such as corn, rice, canola oil, and soybeans, those are the things that are mostly genetically modified. So these are some of the fruits that actually are not genetically modified. They just go in and try to find the right combination of the right combination of characteristics in their DNA structure and bring that out. So it's more of amplifying the things already in the genes than changing it. So now we're going to talk about a tomato. So for the regular tomato, it doesn't bruise easily. But because of the way breeders plant them, they sacrifice the sweetness of it over. So they sacrifice quality over quantity. Because most breeders don't care about how the tomatoes come out, they just want to have it so they can sell and make money. So what scientists are trying to do now is they're trying to compare the Romanian tomato, is it? They're trying to take the Romanian tomato because the thing with it is it bruises easily, but it always has its sweetness. So they're trying to crossbreed them so they can have the sweetness from the Romanian tomato and the firmness from the regular tomato, creating a perfect tomato. And the same thing with broccoli. About 75% of broccoli that I sold in the U.S. actually grows in California, and it grows around Monterey Bay County in the valleys. And it grows there because broccoli is like the fog that comes there. So the thing that happens is when broccoli's, let's say when it's sunny or broccoli is transported somewhere else, they grow but they don't grow properly. So the buds end up, too big or too small. They don't have the uniform budness that makes it aesthetically pleasing. And because of this, scientists are trying to change well, you're not really trying to change the structure of the broccoli. What you're doing is you're planting the broccoli in the conditions it's not used to, so trying to get it to adapt. So when that happens, they extract the buds and the spores from the broccoli that form perfectly, and they replant that. So basically getting the plant to adapt to its weather. And the other thing is, when you eat fresh broccoli, it tastes a lot different than what you buy in the store. Because the broccoli ends up in your stores, it's been transported, and it was on ice before it thawed. And when broccoli is put on ice, it's going to be in a dark place, which means there's going to be no sun, so photosynthesis isn't going to be happening anymore. So by the time that broccoli is taken to the store and defrosted, a chemical reaction starts happening in it. That actually causes it to lose its nutritional value as well as its taste. And that's the end of my slide. In conclusion, most foods are not genetically modified. Well, when it comes to fruits and vegetables, they just go in and try to amplify the things that are already in its DNA to make it better and more healthy for us and make them last longer and give us that sweetness and firmness that we all love in fruits. Thank you.
Any question?
Yes, questions?